Well, welcome everybody to, I think, one of the better seasons, season 6 of the JUXTCast, episode 1. Great to have everybody here. We have a new joiner, Farzad. Hi, Faz.
Hey, hi. Nice to meet you. It's good to be here.
Yeah.
Yeah.
Got a new venue, new room. John, this is your kind of office, is it, in London?
Well, yes, we've got a new office in London. It's a brand new set. We've moved from Milton Keynes back to London, and we brought the table with us. So this is the old table, the old kit. But yeah, it's a new location. It's a new season. Feeling excited to see what's ahead.
And Joe, good to have you back.
Thank you, Malcolm. Yeah, good to be here in the office.
Comedy Joe.
Yeah. Yeah, it's just, just brought Joe in for the laughs. But we're going to talk about our famous XT conference. The last one that we've just had is XT25.
Yep.
How did it go?
Well, it's good. I mean, we're supposed to do it every 4 years, and I'm not sure that's worked out so well. We did 2016, we did 2020, although that was postponed to 21 or 22, and then we did 24, and now we did 25. But I think it went really well. It was in London again, so the year before was Milton Keynes, so we got way more people. The talks were excellent. I think the crowd was good as well, and the vibes were good. So I think it went well. What was the theme, Malcolm?
Well, the theme was going to be about, I guess, like pragmatic solutions to challenging problems or something. I mean, again, the pragmatist aspect of it. But it turned into, because we had Zohar again on the panel, and he wanted to say something he said was heretical. And so we kind of riffed on that, and we were next to the Tower of London, which is where all the heretics used to get thrown. And so we had a bit of fun, and we just started to say, well, anyone can say anything heretical. And so that was the theme, heresy. And I think it worked really well. I think the industry has got way too conservative. I know, of course, we have to be pragmatic, but in places like a podcast and in kind of research and things, we should just be much more heretical.
It's kind of interesting, isn't it? Because like XT16, it was about creativity and engage the play brain, and we had lots of like axe throwing, and it was like, let's have fun, people. And then XT20, which is Spain, we just said, sod it, let's have a rock concert. And we wrote loads of songs and we just performed, and we did our own thing. But the last 2 XT conferences have been more serious. It's been like, well, let's actually look at the real mission and business problem we're trying to solve, and let's look at those solutions. I guess what you're saying is, because you're always a step ahead, you're like, well, let's not forget about actually looking at the other side of it and what is heretical. Let's make sure we don't become too conservative and just focus too much on like what's in front of us right now. We've always got to be thinking a bit more laterally.
I think there's interesting, isn't it, that the industry sort of goes through different periods of divergence when everyone's interested in adopting new things, new programming languages, new databases, etc. And then we also go through periods of convergence, and it does feel like we're in a bit of a convergence period at the moment. Java's back on the march again, and taking over and everything. Lots of languages are falling by the wayside. Lots of smaller technologies are falling by the wayside again. So it's probably time just to make sure that we're still got a steady flow of new ideas and heretical thinking going on.
Yeah, I mean, close to the heart is closure, isn't it? Like, we're huge fans. It's a big part of the company ID, but it's having, is it fair to say, a bit of a harder time out there right now as things converge on the mainstream, the conservative?
Yeah, I think so, definitely. I think for all of these JVM languages or any alternative languages that were thought of as a really good secret weapon for teams, they still are, and they're still there really. But we're in an age of convergence and conservatism again, I think.
I sort of think the old is new again in some ways, and one of the things that kind of drives it. I know that this is a hot topic, and probably, so I want to say the letters AI. And
damn it, we're only like 6 minutes in.
You spell it out for us.
So it's happening. I mean, so I found that when I'm coding on LLMs, which are, when I'm doing it with, say, for example, like something like Java, and then I'm going to compare that to Kotlin, for example, right? And we can compare it to Rust as well, and C++ too. What the machine has been trained with, right, really, really makes a difference. And if you've got a lot of data, a lot of data points for Java programs of various types, then you're going to find that it finds a pathway for you, gives you answers that are more relevant. On the other hand, there was the inventor of Spring, so he's a big converter.
Is that Rod Jeffries or something?
Rod
Rod
Johnson.
Jeffries.
Rod Johnson.
Rod Johnson.
Yeah, and he was on a Kotlin session the other day, and he was professing his love for Kotlin, saying that everything I want to do is now in Kotlin, and actually he gets better quality results because Kotlin is new, and there haven't been so many iterations of what does good look like in a language. Like, for example, with Java, we had so many different iterations of that, right? And
I have to concede that it's very interesting, actually, because I've heard the opposite, that you got to use Python because LLMs are more versed on Python and can sort of do things better, or they've got more experience. But what you're saying is the less kind of crap that's out there, like the eons of time of different styles, goes against
maybe
sort of language choice,
exactly.
Idioms.
Yeah. And then you have like people like Theo, who does the T3 stuff, and he's like going on about how basically everything else is dead. It's just React all the way. And there's a part of me that dies when I hear that. Can I say that? No,
Yeah,
that's my heresy for the day.
Well, let's go on to that heresy. Everything is React now, and if you're doing anything else, then stop what you're doing. Just get onto the React train. So is that the heresy? Or, I mean, because I think that's absolutely not what people should do. But
I agree. Yeah. I think there's better ways of doing it, and I think sometimes traditional HTML is just perfectly fine, really good as well.
It would be a real shame, though, wouldn't it, if this age of LLMs just caused us to get into a place where it was very hard for anything innovative to happen anymore, because we were always relying on a huge body of existing work in order to just be effective with. Now it could mean that people stop thinking about so hard about exactly what programming languages they're using, or exactly what variety of different technologies. They just sort of delegate that to the LLM or the AI that they're using. But it would be you do need people that are breaking new ground, and there won't be a huge body of work always related to some new interesting technical idea.
Yeah, here's my guess. All right, this is a local minima. Right now we're working with models that are very expensive to train. And once you've trained them, you're going to reuse those models over and over again. And there's lots of great work at the moment in play right now for models that can continuously learn, as well as also models that can generate synthetic data. I think the composition of those two will allow for that innovation to proceed again. Just my guess.
Well, a passing comment. I mean, I use LLMs if I am coding. It's only Clojure, because that's sometimes I might get it to generate Python or something, but I wouldn't be the one to judge whether it's doing a good job. But from a Clojure point of view, and a language I know quite well, I think it does a stunning job, and it digs me out of problems that it has no right to know how to dig out. I mean, it's still for me totally magic, and there's nothing I wouldn't say because Clojure isn't very popular or whatever. I mean, the LLMs that I use know Clojure so inside out, and never generate any kind of unbalanced parentheses like they used to, or weird spaces. That's gone. So they're brilliant. I use one kind of every day, and great.
I think those unbalanced parentheses were like the equivalent of counting the number of R's in strawberry, which I think I had problems with, but they've definitely developed around that. And you're right. And I think something like Clojure, because it's so concise, so neat, there's so little fluff, if you like, in the syntax. I think that probably helps a lot as well.
Yeah, I mean, generating small functions, you're not waiting for a long time. I mean, I think it's kind of rewarding people for keeping their programs really small.
100%, yeah.
It's nice to get those moments, isn't it? People often talk about when they're programming, they have sort of little moments of joy, or moments that something happening, something working. It's really satisfying. It's like the LLM when it just solves, as you used to say, Malcolm. It just suggests something that it really is shocking and quite delightful. A surprise. I don't know. Might suggest a comment for a line. You think, how did it know that? That's something that only I know, surely, about the context. So somehow it's already picked this up.
It's like the sort of thing of tie a brain on 4 p.m. on an afternoon. It's like you'd never be able to sort of crank out that change or come up with that functional idea. It just produce it on the spot. It's magic.
But in a way, though, I thank the people who created the code bases out there that actually took the time to document things, because that's all gone into the LLM. It's not the LLM that's doing it, if you like. It's just simply a statistical representation of all that. Yeah. So, here's to the developers.
Yeah, the ancestors.
Yeah, exactly.
Forebearers.
The founders. Yeah.
Well, lots of engineers are worried, of course, about this. We're in the business of hiring engineers, and we're in the business of staffing, and everyone's asking us the whole time, like, what does it mean for the future? And what does it mean? Like, is there a genuine threat, do you think, to engineers going forward?
Well, I take a kind of optimistic view. I think there is always going to be a market for problem solvers, and the form at which problem solving occurs. It used to be in kind of wiring electrical gates and plugs and switches and things, and and punching holes in punch cards, and now that has moved on. So I just don't see. It is incredible and it's kind of quite delightful using AIs in this kind of, maybe it's a golden era. Who knows? Maybe it will turn a corner. But I'm very optimistic, and I think certainly we're trying to find different ways of what actually works. I don't personally use Copilot. I just like to have a LLM side conversation going on and copy and paste code. That's probably because I don't have a lot of code, and so I can very easily paste a whole namespace into an LLM and ask it for advice. But other people's, your mileage may vary. I mean, we haven't had enough experience with this new alien technology to know the best way of using it.
It's interesting, right? Because we should be considering, because we are JUXT, right? We're a professional services company. We staff engineers on projects to solve the hard problems, and now there's a technology that's coming out that's going to make that process far more efficient.
Well, they said that about Cobalt. Cobalt was going to mean business people could write applications, and then the programmers would be made redundant.
Yeah,
and
I'm somewhat optimistic. Although there is short-term pessimism to be accounted for. Microsoft today, I think, mentioned that they're going to release 5,000 developers, I think. And Facebook, I think I read, was something in the order of tens of thousands, if you like. But I think this is either it's a short-termism because they're looking at maybe the next year's budget and they're thinking about tightening that. But I really think that it also could be a kind of a shortage of imagination. So, the world is going to be able to develop so much more now at such great pace. We're just at the precipice of it, and it could really turn asymptotic, if you like. So, humanity's got great potential for creativity. I'm sure we're going to tap that. Yeah.
Well, when Joe mentioned that we're in a period, when we're in a period of great consolidation, and then you go into this ebb and flow, you get to kind of divergence and convergence, and there's this kind of when you're in a period of convergence, people gravitate to the bigger companies. The bigger companies get bigger and bigger, and we're going to bring in more staff. So when Facebook say we're getting rid of 5,000 developers, that doesn't mean the world has just decided there's 5,000 less developer jobs. It just means that those 5,000 developers will be taken up into the growth of new companies, and there's going to be a brand new growth. So it is a signal that we're going out of an age of convergence and into an area of an age of great innovation and new things starting. So I don't weep for those 5,000 programmers. They will be back working in small startups, and that's how things evolve.
Yeah, absolutely. I think so as well. And they're going to be working on new problems. There are so many challenges to solve out there, so many, and we're just getting the tools to be able to address some of them, whether it's to do with material sciences, chemistry, sourcing of construction, of dealing with poverty, dealing with housing. All of these things need solutions in a sense, right? And you're going to have very smart people coming to the table going, how do we build this? And there are going to be elements of that which are going to be unknown, unseen by LLMs, right? So they may be useful for doing discrete parts of that, but there'll be new things that they've never seen before as well. And I think that's where all our smartest minds will move towards.
Yeah, I think that's right. I think the smartest minds, they don't need to be worried. I think, the big commodity play were hundreds of engineers for a relatively not that complicated project. I think those needs will, dry up a little bit. They won't need as many people. So there is going to be a change. But I think for the smart people, as you say, Fuzz, I think that demand is only going to grow. And there's now projects that are becoming in sight that were previously out of sight. So there's legacy systems out there. And we know in these big institutions, it's like a 5 or 10 year project to solve some of these. And they're not simply getting sort of tackled now or put on the slate because it's so expensive, it's going to take so long. Maybe the smart people in conjunction with AI can now start to say, you know what, with the amount of tooling we've got, the amount of insights, analysis that this will give us, we can now start to pick these up and move forward through this huge backlog.
I emphatically agree with that. I'm already seeing it. There's there's definitely a acceleration that this technology provides, and it does change people's perceptions of what's possible. It changes the art of the possible, basically.
Yeah.
Yeah, totally agree with that. So we mentioned React. I just want to, we didn't really continue that conversation. We kind of ended on that note that React is the last word. But whenever you hear people say this is the last word, I remember being in an investment bank when subversion was the last word. We'd finally reached the top of the local maxima, which was the version control system that and all we had to do was move everybody onto subversion, and then problems would solve.
I remember this, because we were working together, and I think your team was the very first team I remember ever using Git.
Yeah, and boy, did we get into trouble. Yeah, but eventually, I think there are, when you think that the world has stopped and that you're finally there. I used an example today. I was talking about kind of Max Planck and that kind of black body radiation problem, and it just is slight, one problem in the whole of physics. They thought physics was completely finished, like mathematics. Classical physics they were just kind of working on dotting the I's and crossing the T's, and Max Planck just kind of realized that this whole summing and aggregation of all the wavelengths would lead to kind of this infinite wavelength, infinite energy or collapse or something, and then just posited one thing, which was, well, maybe electromagnetic energy is distributed as quanta, and that collapsed the entire the entire show had to be rebuilt in the next 30 years, and I think that happens many times in our industry. We've seen that over and over again. Very exciting. I think the most exciting equivalent to that was browsers. When browsers, that Mozilla kind of animation on Windows 3.1 that just changed everything. That was kind of an alien tech thing. So I know I still have nostalgia for those days.
Yeah, it's very true. It's very true. I remember those days as well.
Let's eke this out a little bit, Malcolm, because you've got a heresy about React, haven't you? You think it's
yeah, I think it's too complicated. And I think it's not about React or Angular or Svelte. I think that the entire thing of writing very heavy, complex JavaScript applications is just a terrible idea. And it reminds me of the client-server era where we had incredibly difficult, buggy Visual C++ applications running on a PC, and we were trying to get them to talk to Unix, and they were crashing all the time, and you had to roll in updates, and you had to bring in more floppy disks every time and go around people's PCs. And then that thing was just, it's just the wrong model. You just want to have something like HTML most of the time. And then that's what and it was somehow through just trying to solve some of the latency issues and reactivity issues of these applications, which can be solved in many different ways, we just opted to say, JavaScript. We'll just roll JavaScript out everywhere. And what's happened is we've created enormous JavaScript code bases. And I think they're too expensive. They're too unreliable. If you've ever labored trying to update dependencies on an NPM, huge project, and, the whole thing is broken. And this cannot possibly be the last word.
Yeah, I think also often people have been working in that way for so long that they might have actually lost touch with how effective modern browsers are at shipping large amounts of HTML, downloading, rendering large amounts of HTML, doing that efficiently, looking for opportunities to optimize it. And there's almost just been this huge cathedral of, work built up to try to solve this problem. And actually, a lot of these things are best delegated and solved in a more general way by the browser, by the network protocol, by, different layers. And then, we as application developers, we can just focus on the simple thing that these tools are built for, rather than trying to kind of work around them at all times with more and more sophisticated and complex JavaScript.
Yeah, I'm a big fan of HTML, and I think the most obvious thing that you can do to optimize it is just not load the whole page again with all the scripts and all of the CSS. You just kind of have a way of, a bit like what React does. You just change the bit without loading everything. And the technologies like HTMX and DataStar that are doing that are just seeing amazing performance. The other technology I think that's important is this idea of immediate mode rendering. We know that works on React. You can render the whole, you take the state and you render it, and then you kind of diff it, and you can apply, that very fast, efficient thing that React does is the right idea in the wrong place, because the state isn't in your browser. For most business applications, the state is in a thing called a database, and it's way behind the web server. And so you just need to move that whole idea of immediate mode rendering, go close to the data, not in some kind of microservice or Lambda somewhere. You need to be next to the data, render what the user wants to see with all the access control and stuff, and ship it as fast as you can off to the browser.
I think to some extent, some of the server-side rendering technologies are kind of helping to go that way to some degree. And I think sometimes why people will choose React, I mean, there are various reasons, is the composability. So being able to represent particular discrete, almost business level constructs like components, and then allowing for the HTML to be rendered as part of that component. So having some kind of notion of structuring, if you like. And you can do that in a lot of different ways. And I suppose like you in the pure web stack space, you've got web components, and that's one model that I've seen. If I'm doing something, say, for example, on Kotlin entirely on the server side, I will have small functions that then decompose into HTML. There's lots of ways of doing it. It doesn't have to be just React in that regard. And then back to your point as well, I think when you talked about, what are the sort of benefits that we get, and what are the downsides of writing your own, almost like a programming stack all inside the browser. One of the things that I think sometimes gets forgotten about is security. And there are just so many security issues with browsers. You've got to be very, very careful what you're doing there. And I sort of feel like that gets forgotten, if you like. So much easier to just ship HTML because it's going to be secure, basically.
Yeah, I mean, security is one area where we've got so many problems. If you look at the exponential growth of CVEs, I know that's not all about vulnerabilities, but it tends to be proportional to the amount of code that we're shipping every year, the amount of vulnerabilities we're leaving, and it's almost like such an impossible solution, such an impossible problem. People who think that we don't need many developers, or that the technology is finished, probably haven't seen the extent to how many potholes in the roads of technology we have created.
Yeah, I suppose like the thick sort of TypeScript clients, they would typically have like access to a GraphQL endpoint, and they can submit wherever they want and try things out. And it's kind of dangerous, isn't it, to have those wide endpoints?
Yeah. You want to narrow that down, definitely. Yeah.
I mean, that's of course one of the promises that we potentially got with AI, is that it might be able to, that we may end up with a sort of form of continuous review of source code, of systems. If you've got whatever thousands of agents continuously penetration testing all infrastructure, and everything that you're producing is being continually reviewed, it's one solution to this security problem, the sort of solution of, well, we'll just kind of keep continuing to introduce vulnerabilities everywhere, and we've got better ways of finding them now that scale a bit more easily and could become instantaneous.
Well, that's the good news. I mean, the bad news is that the sort of hacking technology that it has been the preserve of states, and has now the cost of entry has gone so low that anybody can create their own kind of hacking group, and create advanced persistent threats to anything, and so we're going to see a huge arms race.
I think that model though is still one of engineers just continually introducing vulnerabilities, and we just have more effective ways of finding them. And I think we're still, I do wonder, it strikes me that it's not a model that it's not really sustainable. Yeah. Hopefully we're not going to be in that same, we're not going to have that same MO 200 years from now. There's some of these realms of security that need more of a definitive solution, than just kind of relying on just more and more agents to pick up and report the problems that we're creating. So I'm still sort of hopeful that there are, within some of these realms of computing and programming, we'll arrive at some more holistic solutions. In the same way that things like, you might consider sort of, you know, TLS, HTTPS to be something of a solved problem that we can kind of forget about encrypted and you know, communication on the web, for instance. It would be great to have you know, some of these solutions. I think there are formal methods of programming. They're not very accessible or very practical for a lot of domains, but I'm hopeful that we'll see things like that happening. It may be, you know, we may be talking on the order of decades or centuries, though. I don't know.
I'm a bit more positive about that because I think the old way was just grow software by layer upon layer upon layer. You know, you take a Windows operating system with all those kinds of things, and you said, oh well, we'll put that in a ATM or a submarine or something. What can go wrong? You know, it just it doesn't matter really about the amount of code. And I think we've seen a reaction to that, and people realize, yes, it does definitely matter that if you have huge amounts of code, then there's going to be a huge amount of vulnerabilities. So we're seeing, when I look at Docker images, there are people, or even sort of things that run as a single process on the hypervisor, or things that are people really get this thing about, let's be super minimal. And the accessibility of these very minimal images, like Alpine or those, is now, you don't have to just ship a huge Windows operating system now to get something working. So that's a positive sign. People are realizing that more isn't definitely not more when it comes to security.
So I was thinking about scale and the problem of scale. So whilst I think the positive news is there, the likelihood for applying these technologies is a kind of double-edged sword. You can certainly apply it to create something which is maybe more secure, right, based on patterns that we've seen before, right? But usually with sort of new CVEs, it is novel. It does involve some degree of creativity. And maybe I am someone who hasn't completely bought into the level of creativity that's currently possible with LLMs. And that may change, right? Because maybe we'll have systems that have got deeper embeddings. They can embed the notion of creativity in some way. I think if someone was able to find a genuinely new CVE, if you like, that's never been seen before, and you have the human race who is now marching at much faster pace, generating more systems, creating more possibilities, new solutions, that CVE could absolutely destroy a huge amount of work very, very quickly, especially if it's been automated by the other side of that sword, which is the attackers. The rational actors out there, so to speak. So I think scale is going to be very interesting. I don't know if humans do scale very well. That's the thing.
Yeah, but 150, isn't it? Dunbar's number. That's it.
That's right. Yeah.
We drifted back onto AI again. So I wonder I wonder, John, what's your heresy?
What's my heresy?
Yes.
Gosh.
Your heretical view that you want to bring.
If I'm honest, like when I got into Clojure and functional programming, I find myself at odds with some people who still thought that code really, really matters, and you have to really respect someone's code. You can't touch it. It's like you got to do these careful refactorings the whole time. But I just think maybe we're entering a world where code doesn't matter that much, and ultimately it might not be humans actually writing this stuff. Like at some point where AI is just taking instructions, it will be some sort of gloopy stuff that they do, and maybe it can be explained in some way. But I've thought for a while on this trajectory of how much does code really matter. If it gets what the business needs to get done, then is AI just accelerating that?
I think that's a great force. We've probably all seen in teams people raising pull requests, back and forth, lots of nitpicking going on about different structures. This kind of descends into people writing letters back and forth between each other about, why something should be structured a certain way. And it is a real drag on, team sort of productivity when people are really obsessive about getting that code to a place, how they would have liked it to, be written, or how they feel it should be. And so I think, on the one hand, you don't want to throw out all of those ideas about quality because, you may well get into a situation where people are finding it harder and harder to change things. But I think that's always a great force to, a good voice to have in your head. If you're reading someone's code, you might have some thoughts about, okay, how can we improve this? But you should also have that voice to say, just remember that this is not the real goal is the business goal, getting to a destination here. And just remember, always be prepared to think, does this really matter? And
there's been so many debates where someone's got a very strong opinion and then there's a counter argument. Just when you won over to that person, you have a counter argument. It's like, well, at the end of the day, maybe we should stop worrying about it so much. It's as long as it doesn't look completely horrendous to look at and to understand, it reaches some sort of minimum.
Yeah.
But I think it's an economic equation that people are more aware of. I think people are aware of the waste of having these arguments, and if we're a bit more, we're closer to the economics of what we're doing. There's a good blog on our website, JUXT.pro, from James Henderson, which talks about the value of a test and sort of the economics around that. Likewise, Kent Beck's talk at Go to Copenhagen last year was about should you refactor, which was, well, when should you refactor? And I thought, well, yes, you should always refactor, which is an economically unaware argument. He was trying to build in an economic basis for when you should refactor versus when you shouldn't refactor around
all code
options.
is the same, right, in terms of the priority. And don't get me wrong. I mean, I don't think the quality code completely doesn't matter. I think we still need tests. You still need to be able to read it and understand it. But I agree, not all code is the same. Coming back to your nuclear sub analogy with Windows in there, I might want something a bit more polished and a bit more concrete versus some old Windows code.
At the end of the day, it's the business outcome or the human outcome of what we're trying to achieve, and what's going to make a difference, right? Is it really the particular code style that you've used, or is it a particular way that you used, I don't know, ternary functions or ternary operators versus? Probably not. But what does matter are, did it slow my project delivery time, right? Did it fundamentally cause an outage in some form? Did it create a vulnerability? These are kind of things that really actually matter for a business.
Can we change it?
Can we change it? Yeah. Is it maintainable? Can we change it as quick as we?
If all those questions are answered, who really cares what the code is? What's in there?
Who's writing the checks?
But the great thing about working in big organizations is you see the effect of mistakes that were made. That you get the benefit of Captain Hindsight, as I said. You were letting me know about a bug at the place you're working at that, or a design flaw. You said that has actually rippled and created all kinds of costs for future generations. Just one kind of decision that was made in the very kind of germination of that system. And we've all experienced systems that are made so much more terrible by a small number of poor decisions.
Yeah. It's again, the problem of scaling. We can't understand the decisions sometimes that we make in terms of what's it going to look like when the actual system or group of people involved scales.
I still think, though, after the agile movement and extreme programming and this sort of urgency to get to grips and start coding, to prototype and to get in there and start building the solution, I really have come around to this idea that you need to know what the hell you're doing before you start a software project. Just spending some time doing the analysis, the understanding, and that can take quite a while. And it's something that I'm trying to do now with new projects, just slow it down. We need to understand what the mission is. We need to understand the risks, the complexities. It's a bit of a boring message, but you really, really need to do that. Everyone needs to understand the mission. And so often you see engineers not quite understanding what it is they're there to do. They're in some corner of a project somewhere just coding away, producing a local maxima. But it's
I mean, the costs of that are so much greater, right, than really any other cost as part of the software project. The risks of not really understanding at the start what you're supposed to be doing, or working out too slowly, or doing that thinking about what are we actually supposed to be doing here, what direction, what is important about this project. If you discover that slowly over the course of 6 months, without just a bit of effort focused on learning and discovering what you're supposed to be doing, I think without that you can waste. Teams waste years in that, fully eclipsing any waste caused by their code not being in the best shape, or even small numbers of tests or any of these other areas. I think not knowing about what the real mission is.
It's so easy to do that for new engineers joining an existing project. Like, I think something that we need to get better at as a company actually is just when new people join, we take that real time, not just like a perfunctory bit of time to stop, but it's a real time so they really understand the mission and the wider problem that's been solved.
Yeah, emphatically agree. There's a phrase that somebody taught me, I don't know who it was that, maybe it was my woodworking teacher at school, measure twice, cut once. And I think having sort of a clear idea of how everything, all the parts are going to fit together is really important, because you're not trying to just simply build the arm or the back, you're trying to create a chair. And I think that sometimes our organizational structures, like for example, service-oriented structures where you have dedicated teams for each and every service, they sometimes, it's just the nature of humanity in a way. We tend to focus on just the bits that we're working on, and we don't understand the full end-to-end flow. So we can't quite understand what the implications that our changes could be. It's just interesting.
Yeah, I agree with that. I was going to say I'm working on my own microservice, thanks very much, and the code is perfect. But that's exactly that's exactly the mentality.
Code is so beautiful that you can.
And I don't care about your microservices, except for when I have to talk to them.
Well, it's been a good pod, people. I'm kind of tempted to bring in like an oldie, actually. Like, what is the tool of the week?
Well, tool of the week for me is, you mean technology-wise, or
if you really want to bring in something from the kitchen, go for it. But yeah,
no. Well, we've had Connie work with us again. Connie's one of the people we've been sponsoring over the years and brought to conferences and things. She started programming when she was 6, so I think she's around 16, 17.
She's been with us for like probably 10 years. Off
a
friend of JUXT.
Yeah, maybe not that long, but but I think she's 16, 17 now, so she's pretty good, and we've been working on multiplayer tic-tac-toe using DataStar and Clojure backend. She, hasn't been using Clojure in a while and really kind of came back to it and really enjoyed it. So that was good. So DataStar is, for me, the tool of the month. Check with me next week. It might have changed.
Cool. Okay. Next month, by definition. Okay. Anyone else got a tool of the week or month?
I'm having a lot of fun with Backstage at the moment.
Yeah,
I kind of like it.
Do you want to just say what Backstage is?
Backstage is a something that came out of Spotify. It's a integrated developer portal. It allows you to do lots of interesting things. It has a plugin architecture. So from the get-go, you can have, say for example, you have somebody new in your team and you want them to learn about your system. It has a complete service catalog, and it shows you the graph of dependencies, who owns it, which team, who are the people in that team, and you can add new metadata in there. Like for example, how do you release this particular component? Where are the logs for it? And you can put in things like application metrics as well, transactions per second, whatever you're looking for.
Cool.
And it's a CNCF project now. It's quite mature actually. But I think the model that they've gone with is brilliant, because it's almost the same as we saw with Kubernetes, where it's very simple, almost painfully simple, but it's highly extensible. So all the vendors are going in and providing plugins. Lots of people are now deploying it, especially in fintechs, not so much necessarily in banks yet, but it's awesome, I think. That's my favorite.
Cool.
You're going to get a lot of comments, Fuzz, by describing Kubernetes as painfully simple. But but I'm with you. I think you're spot on.
It's easy.
I think you're right.
I'm with you on painfully. But
All right.
On that bombshell. Well, thanks everyone. See you on the next JUXTCast.